Good morning, dear students. Today we will start with chapter 3 matrices. Unlike determinant, matrix is just a collection of data, right? Whereas determinant is the real value associated with square matrix, right? So first of all, we will try to understand the order of a matrix. Suppose one matrix is given. Generally, it is denoted by capital letters. Suppose this is the given matrix. If you are interested in finding the order of a matrix, then we should count the number of rows, slipping lines. 1, 2, 3. Therefore, it has 3 rows and 1, 2, 3, 4. 4 columns. Right. So the order of this matrix is 3 cross 4. The order is taken as row cross column. Right. And the entries inside the matrix are called elements of the matrix. So there are 12 elements in this matrix. Now let's try to understand the types of matrix we have. First is row matrix. In this type of matrix, you will have only one sleeping line and as many as you want standing lines. The order of this is 1 cross 4. Here you can see that row is 1. Right. Likewise, we have column matrix. As the name suggests, it will have only one column. The number of rows can be more than 1. So this is 4 cross 1. You can see that the column is 1. Another is a square matrix. Right. In this type of matrix, the number of rows and the number of columns will be always equal. Here it is having 3 rows and 3 columns. One more example is of this, where the number of rows and number of column is 2. Another is diagonal matrix. This is special type of square matrix where we'll have just entries in principal diagonal and the rest elements will be 0. Right. I can note down this as diag 1, 2, 3. Right. It will have elements on principal diagonal only. Rest all will be 0. Right. One more is that it is a scalar matrix. This is also a special type of diagonal matrix in which the elements of principal diagonal will be equal and rest all will be 0. Right. So this is also a special type of diagonal matrix only, but here in this case the elements of principal diagonal will be same. Right. And the sixth type of matrix is identity matrix. right? It is denoted by I. And this is a special type of scalar matrix where the entries will be 1, right? This can be said as I3, and I2 can be written as 1 0 0 1, right? Identity matrix is also a square matrix, so you will have element as 1 on principal diagonal, right? And rest all will be 0. And the last is zero matrix or the null matrix, generally denoted by O, where all the entries will be 0. The zero matrix can be rectangular matrix or it can be of square type, right? Means the order of this matrix can be of rectangular form or can be of square form, but diagonal matrix, scalar matrix and identity matrix will always be a square matrix. Now let's try to understand equality of matrix. Here in equality of matrix we will discuss the comparison of two matrices, but always remember that equality will only exist if the order of two matrix is same. Here left hand side matrix is of order 2 cross 2, then the right hand side matrix should also be of same order, that is 2 cross 2. The order of two matrix should be equal, then and then only equality will exist, or else it will not. So if I take this A matrix as x y z w and this as 1 2 3 4, right? Then on comparing you can take first row first column element equal with first row first column element of right hand side. Here first row second column element is 5, here first row second column element is 2, so y will be equal to 2. Likewise z will be 3 and w will be 4. This is the equality of matrix, right? This much knowledge is enough to start exercise 3.1, right? So we'll start with exercise 3.1, very first sum. Here one A matrix is given. So this is the given matrix, and the very first question is you have to write the order of this matrix. So if I count the number of rows, then it is 3, and the number of columns, then it is 4. So the order of this matrix is 3 cross 4, right? Next is we are asked to find a number of element in this matrix. So you can just write the product of this order, that is 3 4s are 12. If you will count it, then also you will have 12 elements inside that matrix. 1 2 3 4 5 6 7 8 9 10 11 12, right? Third is we are asked to write down the elements A13, A21, A33, A24 and A23, right? So how to understand that which one will be A13? So always remember that the prefactor written is row and the post factor is column. So this element says that you have to see row 1 column 3 element. So row 1 column 3 element is 19, right? Row 2 column 1, row 2 column 1 is giving me 35. Row 3 column 3 will give me -5. Row 2 column 4 12. Row 2 column 3 will give me 5 by 2, right? Let's understand the second question, where we are asked to write the order of the matrix having 24 elements. If you want to settle 24 elements in a matrix, then the different cases can be considered to settle 24 elements in a matrix. First case is 1 cross 24, means taking row 1 and 24 columns, right? I can settle in 24 cross 1, means I will take 24 elements in row and just one column. I can take 8 cross 3, 3 cross 8, then 6 cross 4, 4 cross 6, 12 cross 2, 2 cross 12, right? So this much is possible, means this many cases are possible to settle 24 elements in a matrix. We can have 8 different cases in which we can settle 24 elements in a matrix. These are the different orders possible, right? In the same question we are asked to have 5 elements in a matrix. So as you can see that 5 is prime, so factorization is not possible. So only 2 cases are possible, that is, one is row matrix and one is column matrix, 1 cross 5 and 5 cross 1, right? Third question is also same, where in first case you are asked to have 18 elements and you have to note down different orders related to that, and in next question, that is in third only, they have asked to settle 13 elements, right? So 13 is again a prime number, so you have only 2 possible cases, that is 1 cross 13 and 13 cross 1. But this 5 is given in third question, and in second question it is given 13, so we just swiped that. So if it is asked 13, in second question it is asked to settle 13 elements, so you will have just 1 cross 13 and 13 cross 1, and in third question it is asked to have 5 elements, so you can note down the solution for that third question. Let's try to understand the fourth question, where we are asked to construct a 2 cross 2 matrix, that is A11, A12, A21 and A22. First row, first column, first row, second column, second row, first column, second row, second column. So we are asked to find this 4 element, and the formula for that it is given. Aij is equal to I plus j raised to 2 by 2, right? So I represents row and j represents column. So here if I am interested in finding a11, then I will take I as 1 and j as also 1. So 2 plus 1 plus 1, 2, 2 square 4, 4 divided by 2 is 2. A12, then I will take I as 1 and j as 2. So 1 plus 2, 3 square, 9 by 2. A21, I will take I as 2, j as 1, whole square by 2. I will again have 9 by 2. And A22 will take I as 2, j as 2. So we'll have 2 plus 2, 4 square, 16 by 2, 8. So the matrix, here the matrix form is 2, 9 by 2, 9 by 2, 8. You can try the second question and third question of this main question 4, where another different formula for Aij is given and you need to find a 2 cross 2 matrix related to that formulas. Let's try to understand the fifth question, where we are asked to again construct a 3 cross 4 matrix. So it will have A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33 and A34. In total we will have 12 elements, right? And the given formula for that Aij is 1 by 2 mod 3i minus 3i plus j, right? So if I am interested in finding A11, then I will take I as 1, j as 1, so minus 3 plus 1 will give me minus 2, so it will be 1. A12 will give me, will keep I as 1 and j as 2, so minus 3 plus 2, I will have minus 1, so it will be 1 by 2. A13, it will be minus 3 plus 3, 0, the answer will be 0, right? Let's find A14, right? I will keep I as 1 and j as 4, so it will be minus 3 plus 4 will give me plus 1, it is 1 by 2. A21 will give me minus 6 plus 1 minus 5, but mod is there, so it will be 5 by 2. A22 will give me minus 6 plus 2, right? A23 will give me minus 6 plus 3, minus 3 will give me 3 by 2. A24 will give me minus 6 plus 4 minus 2, that is 1. Likewise, A31 will give me minus 9 plus 1 minus 8, that is 4. A32 will give me minus 9 plus 2 minus 7, that is 7 by 2. A33 will give me minus 9 plus 3 minus 6 by 2, that is 3. And A34 will give me minus 9 plus 4 minus 5, that is 5 by 2. So just keep that element in the corresponding positions, then I will have 1, 1 by 2, 0, 1 by 2, 5 by 2, 2, 3 by 2, 1, 4, 7 by 2, 3, 5 by 2. Yes, so this is our matrix form 3 cross 4, right? You can find the matrix related to second question where the Aij formula is 2i minus j, right? So you can try that second question by yourself, right? Let's try to understand the sixth question where we have to apply the concept of equality of matrix. Here in first question it is given left hand side matrix as 4 3 x 5, whereas on right hand side it is given, right? So on comparing, I will have 4 is equal to y, first row first column element will be equal with the right hand side first row first column element, right? Z will be 3, x will be 1, and 5 is equal to 5, right? Let's try to understand the second question. Here it is given x plus y 2, 5 plus z, and xy is equal to 6 2 5 8. So if I compare this second row first column, then I will have z 0. If I compare first row first column element, then it will be x plus y is equal to 6, and second row second column element, then I will have x is equal to y. If I take y is equal to 8 by x and keeping that value here, then I will have x square minus 6x plus 8 is equal to 0. Solving this using middle term splitting method, and I will have x minus 4, x minus 2 equal to 0. Therefore x is equal to 4 or x is equal to 2. If x is 4, implies y will be 8 by 4, that is 2, and if x is 2, then y is 8 by 2, that is 4. So we have two pairs of solution, that is one x is equal to 4, y is equal to 2, and z is equal to 0 1, and the second is x is equal to 2, y is equal to 4, and z is equal to 0, right? You can try the third question. You have to just compare it and find the answers. Let's try to understand seventh question. Here also we will apply the concept of equality of matrices. We will compare the left hand side and right hand side matrix. Here the first row first column element is a minus b. Here it is minus 1. Here 2a minus b. Here 0. So if I subtract this, then it is minus a is equal to minus 1. Therefore a is equal to 1. We'll keep the value of a in this equation. So 1 minus b is equal to minus 1. 1 plus 1 is equal to b. b is equal to 2. Right. We'll compare this. 2a plus c is equal to 5. We'll keep the value of a as 1. Then I will have c is equal to 3, and value of 3 c as 3 in this. Then I will have d is equal to 13 minus 9. I will have d is equal to 4. Let's try to understand 8th MCQ in this. It is given that A is a square matrix, and the order of this matrix is A is equal to m cross n. As this is square matrix, the number of row will be equal to the number of column, and that's why C is the correct option. Let's try to understand ninth MCQ. Here we are given two matrices and it is said that these two matrices are equal. That's why we are taking equal to signing between them. I will compare left hand side matrix and right hand side matrix. So I will have 3x plus 7 is equal to 0. I will have x is equal to minus 7 by 3. And if I compare this, then I will have minus 2 is equal to 3x. X is equal to minus 3. As you are having two values of x, therefore, and these two values are also different, you are not getting the same value. One comparison is giving minus 7 by 3, whereas another comparison is giving you minus 2 by 3, right? That's why we will choose B as correct option, not possible to find. Let's try to understand 10th MCQ, where we are asked to form a 3 cross 3 matrix and the elements or the entries should be only 0 or 1. So you can see that I have just two possibilities, or either 0 or either 1, and I have 9 possible places for that. So total number of matrix formed can be 2 raised to 9, right, using the concept of permutation and combination. So there are 512 different possibilities, or 512 different matrix can be constructed using these conditions, that is the entry is 0 or 1.